Good morning, students. Good morning, students. So far in last class, we have completed the task in data pre-processing. Those concepts we have to complete it. So in the data warehousing and data mining, mainly you have to, whenever the data you have to convert it into data warehouses, first you have to merge to the data pre-processing. In the data pre-processing, you have the mainly 4 tasks are there: data cleaning, data integration, reduction, and transformation, and data distribution. Already in last class, we have completed the data cleaning and integration. Now in today's class, we have to discuss with that data reduction. In the data reduction, mainly we have to discuss data reduction mainly means you have to reduce the data. That means, for example, you have the huge data. For example, in a data set, you have the 1,000 records. All the 1,000 records you want to store in the data warehouse, it requires more space. So that time you have to minimize the dimensionality reduction. So you have to that data, entire 1,000 records data, you have to minimize by using these 3 methods. First one is the dimensionality reduction, and the second one is the numerosity reduction, and third one is the data compression. So data reduction. Data reduction obtain a reduced representation of data set that much smaller is in value, but it produces the same analytical results. So simply you can say that here you can see a database or data warehouse may store terabytes of data. Complex data analysis may take very long time to run on the complete data set. For example, you have to consider a particular data set that is the 1,000 records are there. In 1,000 records, you want to store again you have to, whenever you have to calling the data, it requires more, or it requires more space, and it requires the execution time. So it takes a lot of time to retrieving that data. So this type of data you have to minimize, or you have to reduce it. That is the way, by using these reduction strategies we have to follow. That is the data reduction strategies. First one is the dimensionality reduction. In the dimensionality reduction, mainly you have to perform or remove the unimportant attributes. For example, in a particular data set, you have the nearly 15 attributes are there. 15 attributes, but you require only what is the employee ID. For example, you have to take the employee data set, employee ID, employee name, and the salary, and what is the DA, TA, and HR. So these are the attributes only you have to require. Remaining other attributes, father name, you don't want to require. And what is the, whenever you want to give the salary, only few things are needed. What is the name of the employee, employee ID, and what is this scale of the scale, that is the HA, DRA. So for example, you have to consider in that employee data set, you required only what are the important attributes you have to require only those attributes only you have to consider. Remaining, you have to remove, that is the unimportant attributes. While you have to the data you have to reduce it in data preprocessing. Like only what you required. That is the employee ID, employee name, and his salary, HRA, DA. Uh, Only these are the information. What is the salary, present salary? So after reductions, only these are the important things only you have to require. Only that's only that attributes only you have to consider. Remaining other unimportant attributes are we have to remove in dimensionality reduction. So here we have to use the three methods. We have removing the unimportant attributes. First one is the wavelet transforms. That is the wavelet transforms, and second one is the principal components of analysis. That is the PCA, and feature subset selection and feature creation. So these are the three methods we have to use it for the dimensionality reduction. Uh, See here, this is the dimensionality reduction. How we can reduce the data in dimensionality reduction. First one is the curse of the dimensionality. So when the dimensionality increases, data becomes increasing sparse. Density and the distance between the points which is critical to clustering, outlier analysis become less meaningful. So whenever the dimensionality will be increases, uh, whenever the dimensionality you have to increases, uh, dimensionality increases, data becomes increasing sparse. So density and distance between the points of clustering outlier analysis become less meaningful. So automatically data will be increases. Automatically, the meaning of the data you have to uh, the meaning of the data you have to represent it as less. That means it could not be defined as a complete meaning. So, for example, in a particular employee, what you required only that employee's information, what is his salary, only that is those are the attributes only you have to require. But what is the is complete details you don't want to need. So that is the curse of dimensionality. The possible combinations of subspaces will grow exponentially. So ఎప్పుడైతే మనకి నెంబర్ ఆఫ్ అట్రిబ్యూట్స్ అనేది ఇంక్రీజ్ అవుతుందో ఆటోమేటిక్గా that subspace will be increased exponentially. And the next one is the dimensionality reduction. In the dimensionality reduction, avoid the curse of the dimensionality, and for example, unrelevant data like unrelevant data means past experience of the particular employee. That is the in previous what are the attributes are there. Those are that type of data you don't need. That is the help the eliminate relevant features and reduce the noise. For example, in that company was his role. These all things not required. What are the departments you have in previous working college? That is the irrelevant features. That type of data we have to eliminate. That is the dimensionality reduction. You can process here and reduce the time and space required in data mining. So, and also it is easier to visualize. So out of the 15 attributes, you only have to display the 5 to 6 attributes. Easily you can visualize compared to complete data. So that is the way you have to reduce the dimension of the particular data set. What are the techniques you have to use it in the dimensionality reduction? Here you can use the three techniques. You have to use it for the dimensionality reduction techniques. First one is the wavelet transforms, and second one is the principal component analysis, and third one is the supervised and nonlinear techniques. So here wavelet transforms and principal component analysis, supervised nonlinear techniques. Here first we have to consider wavelet transforms. In wavelet transforms, so you can represent it as like this. The data we have to represent. here, whenever we have to map the data in new space, first we have to consider the two types of transformers we have to use. First one is the uh, Fourier transform, and second one is the wavelet transform. So here we can consider in the two sine waves. That is the two sine waves. First sine wave have to started with that from 0 to 1 and -1. So like this way, blue line we have to represent the one sine wave, and the green line we have to represent the another sine wave. So this is the way. These are the two sine waves without noise. This sine wave could not be specified any noise are there, but uh, here you don't have any noise. But whenever the noise will be added to the original data, so the frequency you have to change. So that is the you have to identify it with this wavelet transforms. That is the two sine waves plus noise. We have to represent it in frequency, mapping the data to the new space. See here, what is first one? What is the wavelet transform? In the wavelet transform, it decomposes the signal to the different frequencies subbands. For example, Abhishek, keep quiet. Data here we have to represent. This is the original image. This is the original image we have to represent it here. But this is a wavelet transform. You have to convert this data, converting this original image to this like this way. With the you have to apply the various dimensional signals. After applying the dimensional signals, we get the image like this. So that is the decomposing a signal into the different frequency subbands. Data are transformed to preserve relative distance between the objects at different levels of resolution. Here, it allows the natural clusters to become more distinguishable, used to image compression. So, for example, this is the original image. From this original image, we have to consider from this original image, we have to consider here this original image. We have to convert it into like this by applying the wavelet transform. Very clear? Next one. Wavelet transform, simply you can represent it as discrete and discrete wavelet transform. You have to represent it like this for linear signal processing for the multi-resolution analysis. This is the discrete wavelet transform. And similar way, you have to represent the wavelet coefficients and fraction of this discrete Fourier transforms you have to represent it. Generally, here two types of transforms you have to use. First one is the wavelet transform, and second one is the Fourier transform. Here, in the similar to the wavelet transform, here you can apply the discrete Fourier transform, but better noisy compression localized in space. So here you can take the method how it works in wavelet transform. That is the first method you have to represent. First you have to represent the length. Length must be integer power of the 2, padding with zeros when necessary. So generally you have to represent it as in each transform has two functions. One is the smoothing function and second one is the difference function. So after transform has these two functions we have to applies to pairs of data, resulting two sets of data as length L by 2. Similar way, and the next applies to the two function recursively until reaches the desired length. This is the wavelet transform. Wavelets, a math tool for the space efficient hierarchical decomposition of functions. S equal to, this is the values you have to represent the S subset, that is the S equal to 220,235,44. Can be transformed to in wavelet way. Wavelet transform you have to represent, that is the 2 power 3 by 4 and minus 1 power 1 by 4 and 1 by 2. You have to represent the values 2 to 3 by 4, minus 1, 1 by 4, 1 by 2, 0, 0, minus 1. So these are the values you have to represent it is the wavelet decomposition values. And the next one is compression. Compression. How to compress the data? So here you can compressing the data. Many small detailed coefficients can be replaced by zeros, and only when the significant coefficients are retained. For example, this is the resolution you have to consider 8421. That is the averages we have to represent it as 220,235,44. So these are the average values, and you have to consider that average values. Again, these 8 values are defined as in 4 values, then 2 values, then 1 value. So here, what are the coefficients of this each one? That is, you have to represent it as 4 to 1, 0, minus 1, minus 1, 0, 1 by 2, 0, minus 1, 1 by 4. This is the original frequency distribution for the wavelet coefficients. Use hat-shaped filters. This is the wavelet transform. Emphasize the region where the pointer cluster, suppress the weaker information, their boundaries, effective removal of the outliers. So wherever the data in outside, for example, the maximum mass 100 is the more than 100 you have to represent. That is the outlier. That type of data you have to remove here by using the wavelet transform. Intensity to noise, the intensity to the input order, multi resolution. These are the all purposes you can use this wavelet transform. Detect the arbitrary shaped clusters in different scales. Actually, you have to represent it as a particular marks from 1 to 100 on. That you have to represent it as in different scales, 1 to 10, 10 to 20. So that is the uh, particular 1 to 10, 10 shaped cluster you have to represent it. And a similar way, different scales. Similar way, you have to take the other attributes. You can represent that their clusters. So that is a different, detect the arbitrary shaped clusters at different scales. And next one is the efficient way you have to represent this wavelet transform. That is the complexity is order of n. So maximum the how much of time you have to execute that one, and it is efficient because it requires only order of n. But whereas in previous, where you have to sorting that order of n square, order of n square or order of n cube. So those are the complexities you have to consider in a while you have to sorting the image values. But whenever you have to applying the wavelet transform, only it requires the time complexity is order of n only. So it is a very it takes less time compared to other sorting techniques. So wavelet transform is very powerful compared to other techniques. It is applicable only applicable to the low dimension data. See here, this is the first method you have to complete it for the wavelet transform. Uh, and the next one is principal component analysis, that is the PCA. Find the projection that captures the large amounts of variation in data. The original data are projected. The original data is are projected projected on onto is a much smaller space, resulting in dimensionality reduction. We find the eigenvectors of the covariance matrix, and these eigenvectors define a new space. For example, here in this diagram it shows in principles of component analysis. This diagram shows clearly, it shows all the values must be inside these dotted lines only. Inside these dotted lines. Only what it represents means whatever the data you have, the values we have to consider, and that is the average, that is the original data is projected on much smaller space. These are the points are represented as these are the points you have to represent it as the data, and you have to reduce it, that is the dimensional. We find the eigenvector, the eigenvector values you have to find out for this data. Okay, you can find out the eigenvectors of the values for the this covariance matrix. And final, this is the new space for this entire data. This is the way you have to represent the principal component of analysis. And simply you can say that you can find the projection, large amount of variation in data. The original data are projected on much smaller space, and resulting dimensionality reduction. See here, this is the given data. For example, in the principal component analysis, these are the steps you must be follow. First, given data, n data vectors, n dimensions. Find the k is less than or equal to n orthogonal vectors, principal components that can be best used to represent the data. Normalize the input data. Each attribute falls within the same range. So compute the k orthogonal vector, that is the principal components. Each input data is linear combination of the k principal component vectors. So here the principal components are stored in order to increasing the significance of strength. Since the components are sorted, the size of the data can be reduced by eliminating the weak components. So those we have the low variance, it is possible to reconstruct the good approximation of the original data. Works for the numeric data only for these principles of component analysis. Here you can use the attribute subset selection. Another way to reduce the dimensionality reduction of the data, attribute set subset selection. First one, the redundant attributes duplicate much of the all the information contained one or uh, one or more other attributes. Example, purchase the piece of a product and the amount of sales tax paid. Irrelevant attributes containing the new information that is useful for the data mining task at the end. Example, student's ID is often irrelevant to the task of the predicting students. That is the GPA. Actually, student attribute, student ID, roll number GPA key. It is irrelevant. Okay. Based on work, based on hard work only, we get the CGPA mark. So no, it is not relevant to the student type. Okay. That is the irrelevant attributes. Redundant attributes means here purchasing the price of the product and the amount of sales tax paid. So that attributes are related to the redundant attributes. Heuristic search in attribute selection. There are two power D possible attribute combinations of D attributes. A typical heuristic attribute selection method. First one is the best single attribute and the attribute independence assumption used by the significance test. Best stepwise feature selection, stepwise attribute elimination, and best combined attribute selection and elimination, and optimal branch and bound. So these are the methods mainly you have to represent in a heuristic attribute selection method. So attribute creation, create the new attributes that can be captured the important information on a data set more effectively than the original ones. Three general methods. One is the attribute extraction, domain specific, and the second one is the mapping data to the new space. That is the data reduction, Fourier transform, and wavelet transform, manifold approaches, and the third one is the attribute construction, combining the features for data discretization. This is the attribute creation. These are regarding to the dimensionality reduction methods. So in the dimensionality reduction methods, mainly you have to use the three methods. First one is the wavelet transform, and second one is the in the dimensionality reduction. You have the three methods. One is the wavelet transform, second one is the principal component analysis, and third one is the supervised nonlinear techniques. That is the feature selection methods. So these are the wavelet transform. These are the methods: wavelet transform method and PCA, principal component analysis, and the last one is the feature selection. That is attribute subset selection, heuristic search attribute selection. This is a feature generation. Can represent it here. This is the these all are these three methods are related to the dimensionality reduction. Now you have to discuss with that another method, numerosity reduction method. Generally, in data reduction, you have the three methods: dimensionality reduction, numerosity reduction, data compression. Okay, clear? First one is the up to you have to complete it. That is regarding to the dimensionality reduction. Now we have to discuss with that numerosity reduction. So in the numerosity reduction, we have to discuss reduce the data values choosing the alternative small forms of the data representation. What are the parametric methods we have to use it in here in the numerosity reduction? The example is regression. Regression methods are linear and non-linear regression methods we have to use. So here, parametric methods are simply call it as regression, and non-parametric methods are called non-linear techniques. Here, first one is the regression method. In the regression method, assume the data fits some model, estimate the model parameters, store only the parameters, and discard the data. So, what are the example for these parametric methods? Is log linear models obtain the value at the point in M D space as the product of appropriate marginal subspaces. And the second one is the non-parametric methods. Do not assume models, major families, histograms, clustering, sampling. These are the data reduction methods, parametric data reduction methods. Second one is the non-parametric methods. Generally, these numerosity reduction you have to divide into two types. One is the parametric methods, and second one is the non-parametric methods. So here, first one is the parametric data method reduction methods, regression and log linear models. linear regression and multiple regression and log linear model. So linear regression means generally you have to use in Python program, Python or R programming, we have to use the LM function for the linear regression. And multiple regression, we have to use the GLM function, generalized linear model. So data linear regression method, data model will fit a straight line, often uses the least square method to fit the line. And a multiple regression, it allows the response variable y to be modeled as a linear function of the multidimensional feature vector. And third one is the log linear model, approximate the discrete multidimensional probability distributions. These are the three models we have to discuss in that log linear models in parametric data reduction. Next one, non-regression analysis. How you can analyze this data? In the regression analysis, mainly a collective name of for the technique for the modeling and analysis of the numerical data, consisting of the values of a dependent variable and response variable. Dependent variable is called as response variable, and one or more independent variables, that is the explanatory variables or predictors. The parameters are estimated so as give the best fit of the data. Most commonly, the best fit is evaluated using the least squares method, but other than the criteria have been also used like this. Prediction can be represented as inference, hypothesis testing, and modeling of the causal relationship. So this is the diagram which shows how you have to depending. For example, y value is depending on x. Why? Because y equal to x plus 1. So what is the x value changes, automatically y also you have to change this. So it is the y value is depending on x variable. X is the independent variables we have to represent. Regression analysis and log linear models. Linear regression and multiple regression. Here you have to see the diagram. First one, two regression coefficients, that is the W and B. These are the two other coefficients. Specify the linear estimated by using the data at hand. Using the least squares creation, known values y1, y2, x1, x2, so like this. So here in this linear regression method, y values always is depending on x value. So W and B are the coefficients. So the value can never be changed. Okay. And here the value is changed. If the x is changed, automatically y is changed. So that is simply y value is depending on x. X is the independent variable, y is the dependent variable. That type of methods you simply call it as linear regression. And second one is the multiple regression. In the multiple regression, we have to represent it depends on more than two variables. That is simply you can call it as multiple regression. Y equal to b0 plus b1 x1 plus b2 into x. So here many nonlinear functions can be transformed into four. So here y value is depending on x1 and x2. That is a multiple regression. Next one is the log linear models. So in the log linear models, approximate discrete multidimensional property distributions estimate the probability of each point in a multidimensional space for the set of the discretized attributes based on the smaller subset of dimensional combinations. Useful for the dimensional data. Next one, histogram analysis. In the histogram analysis, we have to represent the entire data. We have to divide it into buckets and storage average of each bucket. So, for example, all 1000 related data, 2000, 3000, 4, 5, up to 10,000. So that is the divide the entire data into the buckets and store the values average sum for each bucket. Partitioning values, that is equal width, equal bucket range, and equal frequency, equal depth. Clustering the data, partition of data set into the clusters based on the similarity and cluster representation. Centroid and diameter only can be very effective if the data is clustered, but not if data is smeared. If you have hierarchical clustering, can be stored in multi-dimensional index tree structures. There are many choices of clustering depending on clustering definitions and clustering algorithms. So in this cluster analysis in depth, you have to discuss in further classes. Next one is the sampling. So obtaining the sample, small sample S to represent the whole data of N. That is the key principles. We have to choose the mining algorithms. Here we can apply. Allow the mining algorithm to run in complexity that is potentially sublinear to the size of the data. So here you can represent the what is the key principle of the sampling is representing of subset of the data. Simple random sampling technique. Sampling may have very poor performance on presence of this two. Developing the adaptive sampling methods, stratified sampling. Sampling may not reduce the database. And types of samplings. Here you have to use the 4 types of sampling methods you have to use. First one is the simple random sampling, and second one is the sampling without replacement. Third one is the sampling with replacement, and stratified sampling. These are the 4 methods mainly you have to use it for that types of sampling. See here, first one is the simple random sampling. There is an equal probability of selecting any particular item. Sampling without replacement, once an object is selected, it is removed from the population. Sampling with replacement, a selected object is not removed from the population. And stratified sampling, partition of the data set and draw the samples from each partition, approximately the same percentage of the data used in conjunction with stored data. So sampling here you have to see with or without replacements. Simple random sample without replacement. So here you can consider the pick the values. 3 balls you have to put in a simple random sample without replacement. Here, these are the 3 values you could not be replaced. But simple random sample with replacement. With replacement, in the place of white, I want to replace with the blue, and in the place of green, I want to replace with the pink. So these are the this is the original raw data. You have to simply that is the SRS WR, SRS WR. Simple random sample without replacement with replacement. Okay, this is regarding to the sampling. So whenever you have to discuss the sampling with the clusters, stratified sampling cluster method. So this is the original raw data. In the original raw data, you have the huge data points are there, but whenever you have to represent the cluster satisfied sample, only you have to consider nearby, or you have to consider as 1 point nearby points. For example, this is in the place of corner, you have to consider this one, and here you have the 2. In the place of 2, you have to consider 1. Here you have to replace the 2. You have to consider 1. Here you have the 3 that you have to consider as 1. This is the cluster and the satisfied sample. And here also similar way can represent the place of these 2. You have to consider this one, and this one you have to consider as these 2. You have to consider as 1, and these 2 you have to consider as another one, and these 3 you have to consider as another one. So similar way you have to represent these 3 you have to consider as 1. This is the one we have to consider here, and here you have to started with that, here you have to consider one. This is the 1, 2, 3. You have to consider. Here you have the endpoints. This is the one, and this is the end one. This one. This is the cluster satisfied. Data cube aggregation. So we will continue in next class. That is the data compression. Data cube aggregation. The lowest level of data cube is basically 2 bytes. The aggregated data for the individual entities for the interest, and a customer in the phone calling is data warehouse. Multi levels of aggregation data cube. Further reduce the size of the data. Deal with reference appropriate levels. Use the smallest representation with enough to solve the task. For example, here queries regarding to this aggregated information should be answered using the data cube and when in multidimensional data cubes. So whenever you want to discuss with the multidimensional cube, that time I want to explain in clear manner. Thank you. Data reduction, that is the last concept in data reduction. First one is the dimensional reduction, second one is the numerosity reduction, and the third one is the data compression. So this is the third point in data reduction. First one is the string compression and audio video compression. Time sequence is not audio. Dimensionality and numerosity reduction may also consider the forms of the data compression. So first one is the string compression. There are extensive theories and well-turned algorithms, typically lossless if you only limited the manipulation possible without expansion. Strings are you have to compress that in this method, and similar way audio and video also you have to compress. Typically lossy compression you have to use it here. Over there in string compression you have to use the lossless compression you have to use, but whereas here in the audio and video compression you have to use the loss compression with the progressive refinement. And sometimes small fragments of the signal can be reconstructed without reconstructing the whole. And the third one is the time sequence is not audio, typically short and very slowly with the time. Dimensionality numerosity reduction may also be considered as the forms of the data compression. This is the original data. This is the original data to have approximated. This is the final compressed data. Okay, this is regarding to this data compression, regarding to the data reduction. So in next class, we'll continue the data transformation and data decomposition.